Hi, sir.
Yes, shall we start?
Yeah, in just maybe 2 minutes you can start. We'll just wait for a couple of students and then we can start. Yeah. Majority of the students are here, I think now. Yeah. And sir, I've made you the host, so all yours.
Okay. Yes.
Thank
yes.
you and all the best. Yeah.
Shall we begin? Everybody, shall we begin? If you can hear me, please respond through the chat box. Okay, so we'll begin. We were discussing in the previous week about the steps in quantitative research. You might have seen those videos. Next, we'll look into research problem, research questions, research objectives, and hypothesis. Research problem means it does not mean that there is a problem. It means that there is a problem to solve. Just like in maths, when we say problem, there is something to solve. No? Likewise, there is something to solve. So problem does not mean that there has to be a real problem which is totally irritating our mind. It is not like that. It is something which we may feel curiosity about studying about something. Okay. So if you feel curiosity about NET exam, what all things you will do? Just think about it. First thing you will be keeping in mind, how can I pass NET exam? So what is the importance of NET exam? All these things you might have studied very well. The importance of NET exam is there are two aims for NET exam. One is what? One is to get a JRF, to give a JRF to the people, fellowship to the people who may write the exam and scores very high. Second objective is to give what? To give a lecturership affiliation if the person is scoring better. These are the two aims of the NET exam. What is the problem which we see when we are approaching NET exam? How can we acquire these two things? So this is the problem which we have. Okay, based on that, we will keep certain questions. What are the questions which we keep? We'll keep the question number one. How can I easily acquire NET exam? Question number two, can I look into the previous question papers? Number three, can I go for a coaching like this? So likewise, we will keep certain questions. We can call this as what? Questions related to our curiosity to take more. That means our curiosity to have a good position in NET exam. Okay. We will have certain objectives also in our mind. After this, if I get a fellowship, I will join a better university and I will get monthly income. So many objectives will be there. Okay. And we will have certain hypotheses also. These kind of questions I will study. Okay. And these kind of questions may be coming. So likewise, when we go for a research, there will be all these elements and we will call it as what? Research problem, research questions, research objectives, and hypothesis. Okay. I will give you the link of a video on null versus alternate hypothesis. This is a very small video. Just watch it. maybe 3 to 4 minutes it will be, and come back. Yeah, here is the link. Oh, it's not the link. I will take the link, I think, and I will put it there. Just a minute. I joined in a different address, I think, no? Okay. Just a minute, I will give the link. By mistake, I joined by a different link. Okay, watch the video and come back. It is a 3 minutes video, 2.06 minutes video. By the time I will try to join the real link. Okay. Give it. Okay. If you have completed watching it, please put it in the chat box. Okay. Now we will just, for our orientation, we'll just have what? Preparation of one, do preparation of one objective problem, etc. We'll try how to do it. Okay. I will open a Word file now. So the problem can be any, which make us curious to find out. So if I am feeling that why some people are easily recovering from the trauma and some others do not. This is what the question which we have imagined. This is what the problem which I felt. Okay, some people are easily recovering from the trauma and some others are not recovering from the trauma. So when I went through the literature, when I read through the literature, I understood that some people have an inner courage called resilience, and this is what is helping them from trauma. Now, how this inner courage is helping them from trauma? What are the factors that is contributing to this inner courage? When I read through the literature, I found that there's so many factors, and some of them are personality factors, some of them are cognitive factors, and some of them are motivational factors. Okay. Motivational factors. I understood like that when I went through the review of literature. Now, I may next think about coming up with a problem like this. Okay, role of cognitive, motivational, and personality factors. Factors in the resilience, and I am more giving importance to the adolescence, this resilience in adolescence. Okay, so this seems to be the problem now. I'm titling the problem like that. Problem can be said as a title. Problem can be presented as a statement, etc. Now, what are my objectives? My objectives can be to find out the cognitive factors related to resilience, to find out the motivational factors related to resilience, and to find out the personality factors related to resilience. Likewise, I have made 3 objectives. So these are my objectives. What these objectives? What is the setup of this objective? Can you just imagine? These 3 objectives are helping us to achieve the solution of the problem. So objectives are just breaking the problem into pieces and placing it. So we can attain small objectives, and through that we can finally solve the problem. Okay, and we can have questions like this. Questions can be like this: what are the cognitive factors related to resilience in young adults? No, in adolescents. So this can be one question. Now the second can be like, what are the motivational factors? And third one can be what are the personality factors. Now we can think about narrowing down this. Cognitive factors, it is not easy for us to look into all the cognitive factors. So we can find out 2 or 3 cognitive factors. Motivation factors is also not easy to find out, to look at all the motivational factors. Personality factors also, it is not easy to look into all the personality factors. So we can do what? We can narrow it down, personality factors into big 5. Okay, motivational factors into like Maslow's 5 different types of motivation, or motivation dimension we can take. Cognitive factors, we can look into learning, memory, likewise any intelligence, some of the cognitive factors we are choosing. Then we can place a hypothesis based on that. Likewise, we will go ahead. And hypothesis can be null or alternative. And you have just heard about what is null hypothesis and what is alternate hypothesis. Those who haven't heard about it, just watch it. Don't forget to watch it. Okay. So this is how we will come from a problem to the objectives, to the questions, and to the hypothesis. Now, before going to objectives or hypothesis, or before framing the objectives or hypothesis, we have to find out certain factors called, we have to understand certain factors called constructs and variables. So what are constructs? Constructs are the elements which we see first, or we experience first. We experience a lot of constructs. A lot of constructs we will experience. Light is a construct, heat is a construct, warmth is a construct. Okay. Imagine parental warmth. Okay. Every one of us might have experienced at least a limited amount of parental warmth. Okay. In future, we may be providing parental warmth. It need not be our direct parent. Maybe some of our distant parent also may give us warmth. Warmth. Everybody know what is meant by warmth. So construct, we can say construct is an experience which we have. Parental warmth as a construct is an experience which we have on how our parents behave on us. So we are experiencing a phenomena. Actually, we are not saying that, we are not exactly saying the parental warmth as a concept as it is. We are saying about parental warmth in such a way that how we experience parental warmth from our parents. Okay. Likewise, temperature. I don't know what is the temperature in your place. Currently, the temperature here is 28 degrees Celsius. So it is not how much is the temperature. It is how I am experiencing this temperature. Based on that, I will talk about the temperature. So construct is something how I experience about the surroundings. Now, when we go for a research, we would like to measure the construct in a way that we experience. Okay. So we will try to measure the construct in a way that we experience. When we start measuring the construct, we'll understand that this will be changing. The parental warmth will be changing from time to time. No? Always the parent may not be providing the same warmth to us. Sometimes the warmth may be high, sometimes the warmth may be low. Likewise, it may be changing from time to time. In certain situations, warmth will be extreme. Certain situations when we are doing something naughty, the warmth of the parent may get reduced a little. Okay, and the approach will be different. It is to correct us. Still warmth is there, but we will not experience that warmth because parent may be showing some kind of anger towards us or hostility towards us. Sometimes some of the parents may show some kind of hostility also. So this change, if we can measure, and we can say that parental warmth of yesterday was excellent than today, then we are looking at the parental warmth as a variable. Because we are taking a measurement and finding out how much it varies from time to time. Then it becomes variable. So constructs and variables are same, but we are looking it in a different way, that's all. Okay. So construct is the basic basic phenomena how we experience. Okay, and variables are our measurement about that phenomena that we experience. This is the difference between construct and a variable. So looking at anxiety, stage fear. Okay, imagine stage fear. How will we measure stage fear? How will we understand that a person who is in the stage has fear? We may look at the stuttering of the person. We may look at the sweating of the person. We may look at the heartbeat of the person. Likewise, there are certain elements which we may understand. Okay, and we will understand if heartbeat is high, then stage fear may be high. Sweating is high, then stage fear may be high. So time to time, we will measure it based on certain variables. Okay, we'll how it varies based on that we will be measuring. So whenever we start measuring and when we find out that it varies from time to time, we can call that particular construct as a variable. Okay, this is the difference between constructs and variables. Now, variables are what we use in the research because we want to find out how it varies. And we used to call something as dependent variables and some other thing as the independent variables. Now, what are the dependent variables? Dependent variables always depend on the independent variable. That means dependent variable will change because independent variable have changed. Now, who will change the independent variable? Sometimes the nature will change the independent variable. Sometimes the experimenter may change the independent variable. Okay. In the case of an experimental research, experimenter will change the independent variable. In the case of an ex post facto research, already the independent variable is experiencing a change, and based on that, the dependent variable also may be changing. So it need not be always the experimenter who is manipulating the independent variable. Sometimes we may not be able to manipulate the independent variable. Okay. Now, the relationship between independent variable and dependent variable is just like what we see here. Okay. See, we can see a switch and a bulb. When the switch is off, the bulb goes off, the light goes off. And when switch is on, the light comes, okay, or the bulb gets lightened. Okay, that's what we can say. We can say this bulb as a dependent variable and switch as an independent variable because the lighting of the bulb depends upon the change in the switch. And change in the switch may be done by a person. Okay, so independent variable is manipulated by a person. That means switch is manipulated by a person. And dependent variable will change as per the changes happens in the independent variable. Okay, this is a physical a physical variable, completely physical variable. Light is completely physical, switch is completely physical, electricity is completely physical. Okay, we can experience it in different ways, but there are certain things which we can only experience but we cannot see. For example, perception. Okay, here in the case of Muller-Lyer illusion, our perception is the dependent variable, and the change which has been made in this arrowhead and featherhead can be considered as what? Independent variable. So when there is a change in the independent variable, our dependent variable called perception is having a kind of change. So what is manipulated here? The independent variable is manipulated here. Dependent variable is getting changed when the independent variable is manipulated. Okay, this is a link between an independent variable and dependent variable. Based on the measures, so we said that we will measure the variables and we will use them in the research. That's what we said. While measuring the variable, we don't know whether we are measuring it completely. When we are measuring the length of a scale by a centimeter scale, imagine length of a particular mobile using a centimeter scale. If I am measuring length of this mobile using a centimeter scale, then I can say that centimeter is the unit which I have used to measure this particular mobile. Okay. Centimeter is somewhat very good physical unit, which has a lot of positives. Why? Because there are no extra dimensions which we cannot see. Almost all the physical elements are like that. We can see it, we can feel it, we can understand it. At the same time, psychological variables are different. When we say IQ, intelligence have 3 dimensions currently, which has been most established. What is that? One dimension, as Wechsler said, is our capacity to think rationally. Second dimension is what? To act purposefully. Third dimension is what? To deal effectively according to the surroundings, according to the changes in the surroundings. Okay. These are the 3 dimensions which Wechsler have used when he developed a measure on IQ. But can we say that these are the only 3 dimensions which it has? We cannot say that. There may be other dimensions also. So almost all the humanities and social science variables, we cannot measure completely. Okay. In the previous class, you might have seen the video on philosophical concerns. In that, you might have heard about positivistic philosophy and post-positivistic philosophy. When we measure a mobile phone with a scale, we are moving with a positivistic philosophy. There is only one truth, that is the exact measurement of this mobile. We can find out the volume of the mobile. The dimensions we know, length into breadth into height is the volume of the mobile. It's very easy to find out. We can see the mobile and we can feel it in our hand. Okay, but when we talk about IQ, we are moving with post-positivistic stance or philosophy or paradigm. Why? Because we cannot identify the complete truth. Here we can identify the complete truth, but in the case of IQ, we cannot identify the complete truth. We can only identify what? 3 dimensions of a truth. Okay, there may be more dimensions for that truth. So what we will do in our research, we will say that our measurement is not complete. Always we will say that our measurement is not complete. We will say that we measured this particular construct based on these dimensions only. And when we say like that, we can say that we have done an operational definition. For instance, here, if I am giving an operational definition of a tool which I am using, imagine that I am using the tool of Wechsler intelligence scale. Okay. So I am writing an operational definition. Intelligence. I will make it a little bigger. Okay. Is operationally defined as I am using the tool of Wechsler. Wechsler has already operationally defined it. Okay. What is that? Think rationally, act purposefully, and deal effectively. So I don't want to repeat the same definition here. I need only say that I am using the tool of Wechsler. And if I am using the tool of Wechsler, then it means it has the 3 dimensions, which is considered as a major part, and it is think rationally, act purposefully, and deal effectively. So intelligence is operationally defined as the score or the IQ, intelligence quotient received for the participant using Wechsler adult intelligence scale. Okay. Sorry. So this becomes the operational definition in the case of intelligence. I need only say like this when I write an operational definition. But if there is no scale, imagine, and if I am using certain dimensions, I have to tell about each and every dimensions when I consider those dimensions to quantify certain constructs or to exactly measure certain constructs. So this is operational definition. Okay. Now, sampling is the next area which we have to discuss. As there is very little time for us to discuss everything, I am giving you certain links to watch. I understand that one of you cannot watch it now, but AQC is coming behind and there may be questions from these areas. Don't worry about it. Okay. Even if you lost some marks in the quiz of this interaction, there is nothing going to be lost. Okay. So I have made a very small video on different types of sampling. I will try to play it here also. Along with that, I will give you the link. So those who like to see it, watch it from the link, you can watch it from there. Others, I don't know how I will play the sound for this. I don't know whether we can listen to the sound when I play it here. Let me see. I'm giving the link for the people who are it is what? Who can watch it directly? Sampling. Can you hear that?
So when you're sharing your screen, you need to enable, once you start screen sharing, there'll be a small box in the bottom left corner that says share computer sound. That's when you need to click it. So if you pause sharing right now and start sharing, you'll be able to do it.
Can you tell me once more?
Yes, so can you stop screen sharing now?
Yeah. Now?
Click on screen share again.
Okay.
On the bottom left, do you see a small box that says share computer sound?
Okay.
Enable that, then we'll be able to hear so.
After that, I have to
click share
disable
after
it.
that. Enable it and only then we'll be able to hear the sounds.
And to hear my sound?
You can hear it on top of this itself, so it will come through.
Okay, great. Okay. Then I can play it from here now. When I explain it, it will definitely take a lot of time. So if I play a video, then...
Welcome to the video series on research methods and analysis by data and research. In this video, we will discuss about sampling methods. Many scientific truths we generalized in the population were based on the findings of the research in a sample of that population. Sampling can be defined as the process by which how we will select the sample from the population. Sampling can be classified into two based on its representativeness of the population. Representativeness is assumed to be high if each member in the population has the chance or probability to be the part of the sample. If the sampling method ascertains this probability, we can call it as probability sampling method. If the sampling method does not guarantee the probability, then we can call it as non-probability sampling method. In probability sampling method, we will choose the participants randomly from the population. Hence, this type of sampling method is also called random sampling method. Random selection can be easily practiced. If the population is definite, as a first step, we can make a list of the participants. Each participant can be identified with an ID. First, we can prepare a set of lots with an ID in each. After preparing it, we will fold the lots and deposit in a fish bowl. Now we can choose one lot after the other from the fish bowl. The individual with the ID in the chosen lot will be considered for the sample. While doing this, we ensure that everybody in the population will get a chance to be included in the sample. For instance, here the first person we chose is of ID 33. The second person is of ID 27. Likewise, I randomly chose 10 participants from the population to the sample using fishbowl technique. What we did now is called simple random sampling. However, this fishbowl method is not feasible if the population is large. In such situations, we will use the table of random numbers. The table of random numbers is a table with a lot of numbers. I can choose the participants based on the numbers one after the other, following a pre-developed pattern. Here, based on a pattern, I am choosing ID number 80 first, then 94, then 252. I can continue like this until I receive an adequate sample. After the arrival of computer, we can have computer-generated random numbers. This is done when using random number generating software. We have to enter the range of the number in this software first. Then in each click, the numbers appear randomly. For instance, the first member ID 93, the second member ID 2006, next member ID 30,657, fourth member is the individual with the ID 165 7000, fifth is 16, and so on. We will do simple random sampling using any of these methods. Stratified sampling is a probability sampling method we may use if we need a representative sample based on strata. For instance, we like to have a sample of government healthcare workers for our next research, and we need a sample representing the whole India. First, we may conduct a simple random sampling to choose the states in India using a fishbowl technique. Imagine that we chose 8 states. This is the first strata. Now imagine that in first states there are 50 hospitals. In the second, there are 60 hospitals. In the third state, there are 30 hospitals. And in the fourth, fifth, sixth, seventh, and eighth states, there are 40, 70, 90, 20, and 30 hospitals respectively. We will select a random sample of hospitals in an exact proportion, such as 5 hospitals from the first state, 6 from the second, 3 from the third, and 4, 7, 9, 2, and 3 from each state. This is the second strata. From each of these hospitals, we will randomly choose the participants again in proportion to the number of healthcare workers. This will become third strata. In area sampling method, we will choose the areas and all the members in the chosen area will become a part of the sample. For instance, while conducting the research on the political socialization among the citizens between the age of 45 and 55 in a Gram Panchayat with 15 wards, we may randomly choose 5 wards. All the citizens aged between 45 and 55 in these wards will be chosen to the sample. In cluster sampling method, instead of area, we are choosing clusters. Imagine that we have to conduct a research among the teachers from an educational district. The teachers in the education district are the members of different clusters. Using a random sampling method, we can choose 4 of these clusters and then collect data from all the teachers in these clusters. If the sampling method cannot ascertain that all the members of the population have the probability to be chosen to the sample, then sampling method is non-probability sampling method. The most popular non-probability sampling method is convenience sampling or accidental sampling method. Here we will select our sample as we meet them. There is no presupposed strategy. We may meet them individually or in groups. We may continue this process until we achieve a sufficient sample size. In judgment sampling, we may take a little more effort to identify the sample. We may frame some criteria to make the judgment about the potential participant. Quota sampling has a similarity to stratified random sampling. We will decide specific quotas for each category in the sample. For instance, we conduct research among government healthcare workers in India. We will deliberately choose states which are easily accessible to us. In each of these 5 states, we will decide as per our accessibility the hospitals from where we may collect data. From these hospitals, we may select the healthcare workers again as per our accessibility to them. Before the data collection, we will decide quota. How many states, how many hospitals from each state, and how many participants from each hospital. Finally, we will have a considerable sample with us, segmented into mutually exclusive groups, such as 1,000 healthcare workers from 3 government hospitals at Rajasthan, 1,000 healthcare workers from 3 government hospitals at West Bengal, and so on. Another interesting non-probability sampling method is snowball sampling. We will use this if we do not have access to potential participants. For instance, we need a sample of HIV patients. We will first approach the person whom we know as HIV positive patient. Through this person, I will find another person, and then another, and then another, and so on. When a snowball rolls over the snow from the top of a snow mountain, its size increases. Likewise, when we move from participant to participant, the sample size increases. Now, isn't there a possibility that a non-probability sampling can, in some ways, be representative to the population? The answer is yes. If we collected a sample of water from a well in a beaker, the water in the beaker represents the water in the well. However, in humanities and social science research, the sample is more behavioral than physical. Still, if we are ready to take a large sample, there is a probability that the sample has almost all the characteristics of the population. We can consider that sample as representative sample. Summing up, these are the most popular probability and non-probability sampling methods. Hope you enjoyed sampling. If you have any questions, suggestions or recommendations, please write to dnr365@gmail.com.
Those who are listening to it, hope you have completed listening that. Hope everybody can hear me, no?
Yes, sir, we can hear you.
Thank you. If you have any questions, you can just place it in the chat box regarding the probability and non-probability sampling methods. And you get, the problem is, it is my rough voice and my rough presentation. I made it for the students for an easy, for them to watch it more and more, and they can learn more. Likewise, I have prepared.
Hi, sir, Ashish here.
Yeah.
Sir, I'm not sure if the students brought this up. Okay. Sir, I think, so they have gone through, they go through paper 1 classes also.
Okay.
And I think also one other faculty also covered some similar portions. So students were, asking that, some of this is something they may already know, but some areas are not yet covered. So
Okay.
I just thought I'll just take this time maybe and just take 5 quick minutes just to share as to what the syllabus is and what they can let us know what is it that they've sort of covered and what is
Okay.
which is yet to be covered, if with your permission. Is that okay?
Okay, you can. No
Yeah.
problem.
So if you can maybe stop sharing your screen, I can just bring up my screen.
Yeah.
But this was really good, sir. I was watching that video. It was quite nice and crisp. So let me
Okay.
just share my screen. Yeah. Uh, Hi, everybody. Can you all hear us?
Yes, sir, we can hear you.
Okay, yeah. Okay, so this is done. This is the unit we are doing, right?
Yeah, research methods and statistics what we are doing. I don't
Correct.
think we will be able to complete it today.
Correct, correct. That's fine, sir. So, folks, what is covered and what do you think where, what is not yet covered? Can you just share?
Sir, I think we've done the first two parts, so paradigms and the one above it. Tina,
Yes, so we've covered the first unit completely, and in second unit we've covered till the end of paradigms, the end of ethnography. From statistics and psychology, the correlation analysis and experimental designs is what we need to cover now.
Oh, I
And that
see.
is what sir was covering, right? Is that correct?
He
I
was
haven't.
covering the
No,
prior part. He's not started this yet.
Okay.
I'm doing it from the beginning. I don't know. When you said the research methods and statistics, I thought from the beginning I have to work on.
No, I think it's yeah. So I think this was a miss from our side that
Yeah.
common that should have been clarified, and that's why. And thanks to the students, they brought it up to my notice, and that's when I thought, okay, I'll just come to the class. Okay. So people are saying this whole part is remaining. The last three.
That area is remaining. I am surprising how we will complete it in 2 hours. I have made some videos here. I have made some slides here.
Correct.
I think if we can directly go to the next area, we can try finishing maximum. That's what you should have told it previous week itself. So I need not.
Correct. Yeah.
I don't know which all area. So when we said research methods and statistics, this whole unit is research methods and statistics.
Correct. So we'll anyways give them more classes, so that's not a problem. And I think even if some of this is probably done again, maybe the concepts will get more clearer. But it's good that they brought it to our attention. So yeah,
Okay.
And you don't have to really cover everything in today's class. But I'm just saying, like, just wanted to bring to your attention. I know in a regular class, maybe people bring it up also, but maybe they're not on video and all that happens. But good that they at least wrote to me and asked me this. So I just thought I'll let you know, but you can continue your flow. But maybe if you have today,
No, I
for
will
example,
start. I'll start from statistics and psychology next.
Sure. Okay, great.
It's easy for me also.
Sure,
At
sir.
least 1 hour. I want it to be very fruitful for them. That's why.
Sure.
So the questions when they receive, they should not be feeling that we did not completed any areas. No.
That's correct.
So I was working on that. Okay.
Sure, sir. Sure, sir.
So I will start from statistics and psychology. No.
Yes, sir. All right. Yeah.
Okay.
Thank you so much. Yeah. All right. Thanks, students. Thanks, students, for bringing this to our attention. Thank you so much. Yeah.
Okay, you people might if you have mentioned it before, I would have directly went there. There is no problem. For me, materials is not an issue. It is already prepared.
We're extremely sorry. So we were very hesitant because you were taking your classes very well and we didn't want to interrupt that flow. I think Vardhini also is put in the chat box.
These slides are prepared for today. For you. If you have told, I would not have prepared these things. Okay. We will start from here then. Okay.
Really sorry for that, sir.
Before starting here, I think you have to know about levels of measurement. So we'll start again with the video on levels of measurement, and then we will continue without knowing levels of measurement. Levels of measurement, anybody have taken?
No, sir, you can start from there, sir.
Okay. I will share a video on levels of measurement now. Oh my God, how much time actually we wasted. Why didn't you say it? Where is levels of measurement? Yeah. And for the people who can watch it directly, I am putting the link also.
Sir, it's actually easier if you just share your screen with the audio because there is no interruption from your side either, sir.
Okay, then I will just share.
Analysis by data and research. In this video, we'll discuss about various levels of measurement. Based on our capacity to measure different objects or events, measurements are classified into four: nominal, ordinal, interval, and ratio. Among these four, tools which we use ratio and interval as the levels of measurement are what we were really exposed as the real tools or instruments using which we can measure something. So, for the sake of convenience, we'll start discussing from the fourth level of measurement, the ratio level. In a centimeter scale, we use the ratio level of measurement. See this paper clip. We can specifically say this paper clip is of 2 centimeter length. And this pen is of 12 centimeter length. Now there is nothing to measure. There is 0 centimeter to measure. Likewise, we can say there is more than 200 milliliter of blue liquid in the beaker here. If there is no liquid, we can say 0 milliliter of anything is there in the beaker. In ratio level, the measurement starts from 0. And from one point of measurement to the other point of measurement, the intervals will be equal. Hence, there will be a standard variation of the scores in a measuring tool with ratio level. These characteristics will allow us to use an adequate mathematical operation with a value received from a ratio level of measurement. We can add, subtract, divide, or multiply adequately as per the need of the measuring situation. The third level of measurement is the interval level. The major difference in the interval level while comparing with ratio level is it doesn't begin at 0. As you can see in this figure, there are a lot of values below 0. This reduces our chance to go for all the mathematical properties using the values from the interval level of measurement. However, as in ratio level, the intervals from one point of measurement to the other point of measurement will be equal. That means there will be a standard variation of the scores in a measuring tool with the ratio level. This enables us to add or subtract the values we receive from a tool that adopts this level of measurement. Usually, measurements in Fahrenheit or Celsius or centigrade is in interval level of measurement. In both ratio level and interval level, the scores or values will be continuous. If there is a need, we can categorize it too, like countries that experience the temperature from -40 to 0 and from 0 to +40 and so on. There are certain situations when we cannot take the measurement in a continuous form. During such occasions, we may use ordinal level of measurement. This level helps us to rank people, like who came first, who came second, and who came third. However, the first, second, and third will not be of equal intervals. We use these values to categorize the people into a certain order. If we are using the values or numbers to recognize the people or place or situations, etc., we are using nominal level of measurement. We use numbers to name the people here, just like our register number, jersey number, etc. These are the 4 levels of measurement. Among these, ratio level is the best in its precision, and nominal level is the least in its precision. And this is how we used to present it. If you have any questions, or if you have
So that is about the levels of measurement. So there are 4 levels of measurement, and based on either of these 4 levels of measurement, we will be measuring each variable. We were told about variable. So measuring each variable will be based on these 4 levels of measurement. Okay. After measuring these variables in different levels, we can make it into diagrams like this. Okay. So if we are going with a nominal level of measurement, we can have a diagram like this. Okay. How many farmers are here, how many industrialists are here, how many businessmen are here. So based on nominal level of measurement, we are doing such a diagram. Based on ordinal level of measurement, we can make a diagram like this. Who is higher, who is lower. Okay. Based on interval ratio level of measurement, we may be making a diagram like this if we are drawing a diagram. Likewise, we can summarize data in different ways. And certain kinds of summarization is a little more interesting, and that is what we can see here in a table. It's also a summarization of data. So it's a data which, imagine it's a data which we are going to use for the next few minutes, next few explanations, or we are going to use it through next few slides. Okay. We are going to look into different measures of central tendencies. Okay, there are 3 different measures of central tendency. One is mean, and second one is median, and third one is mode. Mean, I think everybody know. Mean is a kind of average. When we add all these values together, that means there are so many values here. So we are adding all these values together, and then we are dividing with the total number of values. So that is considered as mean. We used to call this as an average also. But there are other types of averages. One other type of average is what? One other type of average is median. Median happens if we are in ordinal level of measurement. Okay, mean happens when we are in ratio or interval level of measurements. Median happens when we are in ordinal level of measurement. We are writing the whole findings in an order, and we are looking at the midpoint of that particular list of numbers or list of readings, and we can call it as what? Median. Okay. If it is nominal, okay, this is how we can arrange it into different categories. That means how many 2s are here? There are 2 2s. How many 4s are here? 3 4s. How many 6s? 7 6s. How many 8s? 3 8s. How many 10s? 2 8. The 2 10s are here. Okay. Based on this, we can find out how much each of these values, and we can find out that there are 7 6s here. So 6 is the highest frequency which we can see here. We can call this average as mode. Okay. So there are 3 different kinds of averages. One is mean, one is median, and one is mode. Why we are calling this as averages? Because all this talks about the midpoint of a data. Okay, if it is nominal, we will look at the midpoint by mode. If it is ordinal, we will look at the midpoint through median. If it is interval or ratio, we will look at the midpoint using mean. Okay, that's why we are calling these as the averages. And we used to call it as what? Measures of central tendencies. If I am drawing a small graph, that means a bar graph, categorical graph, based on this particular data, it will come like this. Okay. And if I am drawing a line over this graph, it will be like this. If I am arranging a line based on this continuous kind of data, okay, this is a continuous data. Okay, this we have categorized. Okay, this is continuous. Continuous means in ratio form. This we categorized and it became what? In an order. Okay. This is also in an order because we have placed it in an increasing order. That's what we have done. We have placed it in an increasing order. So if we are presenting a curve based on the continuous data, we can call it as a graph based on the continuous data. We can call it as what? A curve. Okay. So this is a curve. We'll call this as a curve. Okay. And as here we can see now, 2 there are only 2, 10 there are only 2, 6 we have 7, so it comes in the middle, and mean, median, and mode comes in the middle. Okay, and we understood the midpoint of the data is what? 6. Likewise, it floats towards both the sides. This is what it has been happened in this figure. Okay, if it floats like this, and if the midpoint like mean, median, and mode is the same value, mean equals 6, median equals 6, mode equals 6, and the data which has been spread inside this particular curve spreads in this way, we can call it as what? A normal curve. We will call it as a normal curve. Okay, normal curve we'll discuss later. We will first look into the next level of measures of central tendency. After measures of central tendency, what comes? See, when people looked into measures of central tendency, they understood that they are doing something wrong. Okay, when researchers looked into measures of central tendency, they understood they are doing something wrong. Why it is something wrong? Because they are only talking about the center. They are not talking about what? The extremes. So some of them thought we have to talk about the extremes also. Then only we can say completely about a particular data. So talking about the extreme, they called as what? They called as dispersion. Okay, or they called in a particular title called measures of variable tendencies. That's another kind of expression, measures of variable tendencies. This is a different data. This is not a data which we have seen previously. This is a different data because we need a little more better number of data to talk about measures of dispersion. So people thought how we will find out the maximum of the maximum and minimum. How will we talk about the maximum and minimum as we talk about the middle? Okay, if it's a small data like this, it's very easy to tell about the maximum and minimum. But if it is a huge data, then it won't be so easy. So we need certain calculations. The first calculation which they came up is the range. They need only add the maximum score and minimum score, and they can find out how many scores are there in between. And they call it as what? Range. Okay, so range is just like maximum score minus minimum score, and what are the scores that are coming in between. So here the maximum score is 10 and minimum score is 2, and how many scores are coming in between? 8 scores, and they call it as range. But range is not explaining everything. They understood, so they tried looking into something different. Based on median, they started calculating something different. Why they went for a median? There are many reasons for that. I will explain the reason later. Sometimes median may not be a fixed middle. In that case, we will just add the mid two values and then take an average of it. That's what we will do. Actually, this is not the way to find out the median. But for the sake of learning, we are looking into this. Okay, looking into this way to make it to have a simple kind of learning, that simplified kind of learning. We have prepared it like this. So median can be like what? Median can be, if there are 2 values in the middle, we can add those 2 values, then divide by 2, and we can find out the median. Okay. And now, how much is the other scores away from the median? This is what people used to think. People started thinking how much other values are away from the median. So they looked what? They again took the middle of the values above the median and below the median. Okay, the scores above the median here is 65, 76, and 87. I have written it in ascending order. No, so The scores above the median is 65, 76, and 87. The scores below the median are here 43, 34, 23, and 12. So these are the values. How many values are there above the median? Above the median, there are 7 values. And below the median, again, there are 7 values. Out of this, I can take the middle again. And the first value below the median, I called as what? First quartile. Okay. The middle value, it is median. And the mid value above of this, of the upper 7 of the data, I called as what? Third quartile. So where is the second quartile? Second quartile is the median itself. Okay. So the first quartile is the midpoint of the first 7 below the median, and third quartile is the midpoint of the 7 values above the median. Likewise, I classified. Why I am calling this as quartile? There is a reason for this. Okay, why I am, no, I haven't. I will draw it and I will explain. Okay, why I'm calling it as a quartile. Based on this, I can classify this data into 4. How I can classify this data into 4? If I am saying that all the scores above first quartile, so this becomes the first section of this data. All the sections in the second quartile, that means median. So this becomes the second section of this data, and all the values here before and after the third quartile. So this becomes the third portion of this particular data, and this becomes the fourth portion of this particular data. Likewise, I can classify data into 4, and I can find out how much each of this data is spread. Okay, so I am drawing a box here, and in the median position, I'm drawing a line like this. Okay, and if I am spreading a whisker towards here, towards this edge, and if I am spreading this whisker towards here and this edge, then it becomes what? It becomes a box plot. Through box plot, I can find out how much each of the values are spread below the median and how much each of the values are spread above the median very easily. So using quartile deviation, I can find out how we can calculate the quartile deviation. Okay, we can calculate the quartile deviation like this by looking at the interquartile range. Okay, I can find out the difference between the Q3 and Q1, the difference between these two, and I can find out what? Interquartile range, and based on interquartile range, I can find out the quartile deviation. So quartile deviation is a way using which we can find out what? How much the data is spread below and above a particular average called median. But many people are not okay with this median and quartile deviation because it's not giving a precise kind of explanation about the spread of the data. So they are more interested in some kind of calculation based on mean. So they came up with the idea mean deviation. How much the values are deviated from the mean. So they found out that if mean is 6, the smallest data 2 is deviated from the mean with a difference of 4. Okay, that means 6 minus 2 is 4. Okay, so if the total data we can call as x. Okay, the total data we can call as x, and total data we can call as x, and the difference, the mean we can call as x bar. Okay, if the mean we can call as x bar, then I can find out the mean deviation by subtracting each score from the mean. So here 6 minus 2 becomes 4. Here 6 minus 2 becomes 4. Here 6 minus 4 becomes 2. Here 6 minus 6 becomes 0. Here 6 minus 8 becomes minus 2. And 6 minus 10, it becomes minus 4. And if we add all the mean deviation, what happens? It becomes 0. Actually, almost all the people who worked in that way, finding out a method to understand how much the data is spread from the middle using a mean deviation, they were totally fallen into the despair. They started crying, how can we find out a new method? And some of them thought, to remove this negative sign, we can do what? We can just square it. And later, doing all the calculation, we can find a square root also. Okay, so they started squaring it. So 4, they squared it, 16. Minus 4 into minus 4, it became plus 16. Minus 2 into minus 2, it became plus 4. Plus 2 and plus 2, it became plus 4. And then they added it together. Okay, so they first squared it and then added it. First they squared it and they summed it. And because of that, they called it as what? Sum of the squares. Okay, here sum of the square is what? Sum of the square is 96. Okay, when they added it together, it became 96. Now they did what? They subtracted it. As we find out the mean, they subtracted it with mean, n. So sum of the squares by n equals 96 by 25. That equals what? 3.84. Okay, so how is the spread? 6 minus 3.84 have to be the spread towards this tail, and 6 plus 3.84 have to be the spread towards this tail. But 6 minus 3.84 is not 2, and 6 plus 3.84 is not 10. Again, they fallen into a lot of grievances, confusions, etc. Suddenly one person came with a solution. What is that? We can use what? We can use a particular method, a tactic. If it is a small sample, just subtract the total with 1. Okay, so we can easily find out the exact spread of the data. This is what somebody have found out. And this gave them a lot of freedom. And because of that, they called this particular notation as degree of freedom. Okay, degrees of freedom. This is what, this is just a story. It is not actually like this. I'm just telling it because we can remember it in that way easily. Okay, so they called it as degrees of freedom. Okay, now look at here, 6 and 6 minus 4 is 2, spread towards left. 6 plus 4, it became 10, spread towards right. Exactly the value, the exact spread we are getting if we are doing like that. They found it out like that. Okay, likewise, they are satisfied and they lived forever. But we are still studying about it. We called this particular formula, sum of the squares by degree of freedom, we call this as variance. If it is a large sample, there is no need of degree of freedom. We can directly go with n. If it is a small sample, we need the degree of freedom. Then only we can find out the extreme end. Okay, the right extreme end. And they remembered one thing. What is that? They squared here. So they did what? They found out a square root of it. And surprise. What is the surprise? When they found it, they understood that when they found the square root of it, they understood the score is 2. That means 6 minus 2, it became 4. 4 minus 2, it became 2. And 6 plus 2, it became 8. And 8 plus 2, it became 10. For each unit, if they add 2 or the standard deviation, it is going step by step. And they called it as a standard deviation because there is a deviation happening. It talks about a deviation which happens in a standard form from one position to the other position. Then they call it as what? Standard deviation. Okay, so this is the story of variance and standard deviation. Why they square rooted here? Because they squared here. Okay, they found the sum of the squares here. That's why they square rooted here. So what is the formula of standard deviation? This is the formula of standard deviation. You can try it, try doing standard deviation. So this is one of the most important measure of dispersion, what? Standard deviation. And variance is also one of the most important measures of dispersion. Variance, it is not easy to compare with other. That means imagine that you have a particular measure in ratio variable, another measure in interval variable, And another measure in discrete form. Discrete form means there are no points in between. Okay. In continuous form, there will be point 3.1, 3.7, 3.8 likewise. But in discrete form, it will be like 3, 4, 6, 8, like 3, 4, 5, 6, 7, 8. Likewise, it will go. These are two different scales, we have to say. These are two different scales. One is in discrete form and another one is in completely ratio form. One can be considered as somewhat in interval form and another can be considered as somewhat in ratio form. And discrete may be considered as a value in ordinal form also sometimes. If you want to compare these two using variance, it will be difficult, but we can easily compare it based on standard deviation. So we can call it as what? A standard score. Okay. Now, if you have any doubts on that area, just give me a chat. I will. Where is my chat box? My chat box. I'm in search of my chat box. If you have any question, you can open your mic and ask. I cannot see my chat box, so I will look in the chat box in the end.
Sir, as of now, no one's written anything. I think it was pretty clear.
Okay.
I was just a little confused between the difference of interval and ratio. If you could explain that once more.
The best point to remember is ratio starts with 0. Interval doesn't start with 0. It is before. Okay. Ratio does not have any value below 0, but interval have a lot of value below 0. Like negative 40 degrees Celsius, negative 30 degrees Celsius, all these are interval level of measurement. And as the values are there below 0, we cannot multiply or divide it. But in ratio, 0 is the beginning. So we can multiply and divide those values, because when in the ratio form, we can say 1 into 0 equals 0. But in interval form, 1 into 0, maybe 0, but that 0 has something in it. 0 degrees Celsius is a time when we cannot multiply it. 1 into 0 cannot happen in in interval level of measurement. This is a major difference.
Sir. Yeah, now I understood. Thank you.
Both are almost same. Okay. We will
Yeah, that's
call
why I
both.
got confused.
We will call both as continuous variables, continuous values. Okay. Now everybody know what is population and what is sample. Sample is a part of the population. Okay. There are two different types of sampling. We already know that, but I cannot proceed without mentioning these things here. Okay. So keep that in mind. See why we are calling it as random. Because everybody in the population have a chance to be a part of the sample. Okay, if you do not understand it properly, just watch that video on sampling. You will understand about it more. Sometimes that means everybody have the chance to become a part of the sample, means everybody have the probability to become the part of the sample. Sometimes everybody may not get a chance to become a part of the sample. There are situations like that. We cannot always look into a random sampling method. For example, if we are collecting data from a set of cyclists in a particular town, we don't know what is the total list of the cyclists. Only if we get a total list of the cyclists, we can randomly choose them. Here we have to directly go and find one person and collect data from him and come back. So that person will become a part of the sample. So everybody does not have a chance to be a part of the sample. We'll call it as what? Non-probability sampling method. Okay. See, this is a curve. You remember the curve which we have told. If we draw a curve on a measurement of a population, the curve will look like this. This is an ideal curve. We think that almost all the population is like this. For instance, if we are looking at the IQ scores of the people in Delhi, everybody, all the people, if we are collecting the IQ scores of the people in Delhi, then the majority of the people will come towards this position. Just a minute. Take the pen. Majority of the people will come towards this position, and minority will go towards this. Minority means what? A person. So imagine this is 100. Okay, majority of the people will have 100 as their IQ, and this is 80, and this is 120. So what does that mean? Mean is 100 and standard deviation is 20. Okay, so 100 plus 20 is towards right, 100 minus 20 is towards left. This is what mean. Okay, so standard deviation is 20, mean is 100. Then if standard deviation is 20, then from this particular position there will be another position here plus 20, that will be 140. And there will from here there will be a position here, that will be 80 minus 20, it will be like 60. There will be a position like that. Okay, likewise people with lesser IQ will go towards this side, and people with higher IQ will go towards this side. This is what this particular diagram or the curve showing us. So if we are collecting the data on IQ in the population of Delhi, and if we place, if we draw a curve on that, the curve will be like this, is the assumption. We are looking at the population here. Now, if we are looking at a representative sample, that means we said random sample, probability sample. If we are taking a probability sample, the curve of that probability sample will also be like this, because at least as everybody have the chance to be a part of the sample, everybody in the population had a chance to be a part of the sample. A person from many people from here might have become the part of the sample, and at least one or two people from this side also may become the part of the sample. Then only we can call it as representative. Okay. So imagine that we are taking out of 4 lakh people, I am taking only 1,000. This 1,000, if I am collecting the IQ scores randomly, it will be spread like this, is what we assume. Okay, this is what our imagination is. Okay. Now, as I said, cyclists in a place. We cannot have random sampling always. It's not possible to go with the random sampling always. That's what this particular figure showing. Okay. Okay. Random sampling always possible? No, we cannot have a random sampling, because the list of the people may not be definite in all the situations. The list of the people in the population may not be definite in all the situations. It may be somewhat endless or unlimited or undefined. Okay. If we are taking in such situation, if we are taking large sample, there is a law of large numbers. It shows that large sample will be telling about something about the population. Then we can assume that the curve may be like this. For example, if there are 3 lakh people, around 50,000 people data we are collecting, imagine. Then we might have somehow collected people from almost all the areas, definite. Even if it is 10,000, we might have collected almost all the representations of this particular population. Even if it is 1,000, it's okay. We can say somehow we might have reached a large sample, and we know that somewhat this is the distribution of the people. But if it is 100, we cannot say like that. Okay, we cannot say that it is representative. We might have only collected data from this particular set of people. Otherwise, we can say that we might have collected many. Okay, just a minute. We might have collected data from at least these set of people. We might have collected data. We might have chosen if it is a large sample. If it is a small sample, we cannot say like that. So what happens? We have to say like the data is somewhat skewed like this. Okay, this will occur in a small sample. Okay, this is called as positively skewed. If the tail of this particular one is towards right. All these areas are covered. Please tell me if it is covered.
No, sir, we haven't done anything.
Okay.
Any of it.
If the length of the tail towards right is larger, we can call it as what? Positively skewed data. And if the length of the tail is longer towards left, we can call it as what? Negatively skewed data. We'll call this as what? Skewness. Okay. Now, if it is like this, what does it mean? It means that we didn't have the data from this side and this side. This is what it means. Okay, this we will call as curtic. Okay, and this here we can see it looks like a leap. That means it is peaked here. It is too much. We may feel that it is too tall. Actually, it is not too tall. But we may feel it is too tall, and we will call it as what? Leptocortic. Okay, we will call it as leptocortic. Now, here, see, we lost data from here. These much of areas we lost the data. Okay, this is somewhat like platy. Okay, I don't know whether I have drawn another. This is platycertic. Okay, this is platycertic, and there are situations we may feel, oh, I haven't drawn that. I will draw it here. There are situations we may feel like this. Okay, there are certain curves like this. We may feel this is somewhat normally distributed because it looks like normally distributed, but we lost data from here, these areas, we lost data from these areas, and we lost data from here also. And we will call this as mesokurtic. Okay. So kurtosis means we lost data, or we haven't have a representative sample. Skewness also says that we lost data or we don't have a representative sample. Okay. If it is like this, it reaches towards both the tails in a perfect general way. And if we break this here towards here, it is just like mirror towards here. And if mean, median, and mode comes towards the middle, then we can say that the data is normally distributed. Okay. This space, we'll call this space as asymptotic, the space in two ends. Why asymptotic? Because we think that the sample is incomplete. We haven't received all the sample here. Again, people are there. So there has to be a space which shows that there may be again extremes which we haven't got in the sample. Okay. If we break this curve in the middle, both the sides are somewhat mirror-like. We will call it as what? Symmetrical, bilaterally symmetrical. Okay, we'll call it as bilaterally symmetrical. These are some of the characteristics of a normal probability curve. We'll call this as what? A normal probability curve, and these are some of the characteristics. Okay. Now, we can do normality testing. I can give you the link towards normality testing. I don't think I will be able to let you watch the video. You do one thing, you go to that channel and you watch that video on normality testing and interpretation. Okay, you will understand more about it than we do a class about it. You can relax and listen to that particular lecture on normality testing and interpretation. Now, I have very briefly, as I thought I won't get enough time to discuss about all the tests, I very briefly written about the different tests. Before that, now I have to tell you something here. Okay, here. Here. See, if the sample is really representing the population, okay, we told that we will take a measurement of IQ among the population. And we will look into the mean and standard deviation of the IQ among the people, whole people in Delhi. Imagine like that. And we are looking at the mean and standard deviation. If we are looking at the mean and standard deviation of a population, of a whole population, we are not doing statistics. We are doing parametrics. Okay, so any calculation which we may do in the population, we call it as what? Parametric. Parametric. Metric means a kind of measurement. Okay. Any calculation which we do in a sample, we will call it as what? Statistic. So if we are doing a calculation in a representative data like this, okay, in a representative data like this, that means a data which is exactly representative to the population, then we will mix these two terms together and we will call that statistics as parametric statistics. At the same time, if we are doing a kind of calculation in a data which is not representative to the population, we will call it as non-parametric statistics. So there are two different types of statistics. One is parametric statistics and another one is non-parametric statistics. Now in that group of videos, there is one video saying that which test we will use. That means which hypothesis test we will use in what kind of hypothesis. There is one video like that. You have to watch that video. Okay. I will be telling it very briefly, but if you want to understand it more, you can watch that video. If our hypothesis is like this, if we have two groups like males and females, and if we have one variable, here resilience is the variable. So resilience is in which form? Either ratio or interval form. Okay, the scores of resilience, the scores of IQ, etc. are either in ratio or interval form. Then there may be a question, in which form exactly it is? We cannot say. Because we calculate resilience based on a Likert scale carrying questionnaire. Okay, almost all the Likert scales are first of all ordinal in its form. So I like jackfruit or I like pineapple. Strongly agree to strongly disagree. Strongly disagree is 1. Disagree is 2. Neutral is 3. Agree is 4. Strongly agree is 5. So there are 5 options here. I placed it in order. 1, 2, 3, 4, 5. I've ranked them in order. I have to say like that. I have ranked them in order. So it is placed in an order which can be considered as what? Ordinal level. But if I have placed so many items like that, and if I am counting all these scores which a person, a respondent has given, then I will get a score which is looking like interval. Okay, now when I standardize it, okay, when I standardize the scale, I am looking at a huge number of people. So I am comparing with a huge number of people. Immediately, it becomes a particular kind of interval, which some of the statisticians called as plastic intervals. Not right intervals, but plastic intervals. Hooligan has called it as plastic intervals. Okay. Almost all the scales which we have are of plastic intervals. Okay, so resilience, what is the minimum score of resilience? It will definitely never go below below 0. Okay, it will not go even below 20, maybe. I don't know. Some of the scales may have 20 as a score, lowest score. So there is no chance that anybody will get a 0 in a resilience scale. So usually we will call it as what? Scale, which is either interval or ratio. Okay, so here resilience is, the scores of resilience is on the scale of either interval or ratio in the level of measurement. But males and females, you know, it is a nominal level of measurement. Okay, so if we are comparing one variable an independent variable with nominal level of measurement, and a dependent variable with interval or ratio level of measurement, then we will use independent sample t-test for parametric as a parametric statistics. Okay, so independent sample t-test, we will assess.
Can you repeat that?
Yeah, I will repeat once more that if the independent variable is in nominal level of measurement and the dependent variables are in interval level of measurement, then we can go for independent sample t-test. So IV is nominal level and DV is interval or ratio level. Okay, only condition is the DV or the dependent variable which is in interval or ratio level is normally distributed. It has to be normally distributed. Okay, if it is not normally distributed, then we have to go for non-parametric. So normal distribution is just an indication that our data is representative to the population. Okay, if it is not normally distributed, then it is not representative to the population, and any calculation which we are doing in that sample will not be identical as the calculation which we do in the population, and because of that it will go for non-parametric, and we have to use a non-parametric test to get an exact answer, and that is Mann-Whitney test. Okay, one example is Mann-Whitney test. There are so many other non-parametric statistics which I also am not aware about. Okay, in non-parametric statistics, why we are using non-parametric statistics like Mann-Whitney test? Mann-Whitney test is not depending on mean. That's the main reason. Independent sample t-test depends on mean and standard deviation, but Mann-Whitney test depends on median and quartile deviation. Okay, so in the case of Mann-Whitney test, we are ranking the data. How we are ranking the data? I will show you how we will rank the data. Okay, discard, and we'll go to the data again here. Okay, this is the data. Among this, which is the lowest? 2 is the lowest. And there are 2 2s here. Okay, this will be complicated for you. So I will open one Excel and I will show you. EXCL Excel. Okay, there are certain marks there. I will, for the sake of convenience, if you don't tell it to anybody, I will copy these marks from here. And I'm sure that you are not there here. And don't read any names here, okay? Control C. Okay. Oh. These are the values. See here, there is 11, 12, 13, 18, likewise the values. Okay. Now I can do first what? I can do first sort it from the smallest to the largest. Like this. Okay, it is sorted. Okay. 0 is here. I am using only 1 0 here. Imagine. Okay. I am ranking this as 1, 4 as 2. The next value is 11. 11 as 3. Next is 12. There are 2 12s. So I won't put it as 4. I will put it as 5. And this also as 5. And no, I will put this as 4.5. Okay, 4.5. And I will put this as 4.5. Okay, so this is 4. This is 5. And this can be considered as 6. Okay. Now, how many? There are 3 14s here, 7, 8, 9. Okay, so I will put as 8, this one, 8, 8. Okay, so next have to be 10. But there are how many? 15. Likewise, the ranking will go. I am so sorry if you did not understand. The ranking will happen like this. I will rank each scores like this in the data. And I will do the analysis on these ranks, not on this data. So man-Whitney U test is done on this rank. So always this rank will be equally distributed. Because it is just like 1, 2, just like in Likert scale, strongly disagree is giving 1, disagree is 2. Likewise, it has been ranked. No? Likewise, I am ranking these scores here into a different pattern of numbers, and I am doing my calculations on those ranks. So there is no problem even if it is not normally distributed. That's the logic behind it. Don't worry if you did not understand ranking. If you have understood the logic, that's excellent. Tell me if you understood the logic or not. Just give me a hint about it.
Yes, so I think most of us understood. It's on the chat box as well. Yeah.
So in non-parametric test, which we call as man-Whitney U test, again, the independent variable have to be in nominal form. Okay, dependent variable, even if it is in interval form, we will convert it into ordinal form, and then we will do the analysis. Okay, there is something called homogeneity that I will talk later if we have a time or if we get another class. First, let me go through some of the tests like this. Now, imagine we have instead of 2 different categories. Previously, it was male and female. No, we have 3 different categories in independent variable. Okay, if there are 2 categories, we can go to independent sample t-test or man-Whitney U test. If independent variable is in nominal form and it has 3 different categories, and the dependent variable is again, as we said before, is an interval or ratio level of measurement, then we will go for one-way ANOVA if it is parametric. If it is parametric means if the dependent variable data is normally distributed, then we will go for one-way ANOVA. I will tell it once more. If the independent variable is in the form of nominal level of measurement, and there are 3 categories here: lower class, middle class, and upper class. There are 3 categories. Or if it is, even if it is 4 or 5 or 6 categories, no problem. Okay, no problem. If it is 3, 4, 5, whatever may be the number of categories, we will go for one-way ANOVA. If the dependent variable is in interval form or ratio form and it is normally distributed. If there are 2 categories, we'll go for independent sample t-test. Okay, if there are 3 or more categories, we will go for one-way ANOVA. If the dependent variable is not normally distributed, then we will go for Kruskal-Wallis H test. We'll call it as what? Kruskal-Wallis H test. So Kruskal-Wallis H test is the non-parametric equivalent of one-way ANOVA. So both independent sample t-test and one-way ANOVA has one similarity. What is that? The dependent variables will be somewhat similar, but they are contradictory in one thing. What is that? The independent variable will be 2 categories in the case of independent sample t-test. The independent variable will be 3 or more categories in the case of one-way ANOVA. Okay, and non-parametric equivalent of independent sample t-test is man-Whitney U. Non-parametric equivalent of one-way ANOVA is Kruskal-Wallis H test. Okay. Now that is about one categorical and other continuous data. Okay. Now, if we are doing an experimental design, it will not be like this. This is just ex post facto research designs. If you don't know about the quasi-experimental design, again, there is a video on quasi-experimental research designs in the in that particular channel. If you don't know about experimental designs, there is a video on experimental designs also. You can watch those. Okay, I will try to explain it precisely in maximum simple way. Now, if we are doing an experimental research with a pre-test and post-test. Okay, so two different testing situations are there. Okay, a pre-test, then an intervention, and a post-test. Now, pre-test scores of resilience are there, post-test scores of resilience are there. Pre-test scores of resilience are in scale form, that means in interval or ratio form. Post-test scores of resilience are also in interval form. Pre-test scores of resilience, excuse me?
I have a doubt, sir.
Yeah.
So the selections of the particular test that we are going to use is completely rigidly based on the levels of measurements of the IVs and the DVs, or it is a bit flexible?
This is all linked, very closely linked. Okay, actually the test we will choose based on the hypothesis we have. That's why I put the hypothesis in the upper side. And the variables here when I say resilience is the dependent variable. An independent variable is the intervention. And the scales, levels of measurement. That means the level which the variable have. These three have to be considered if we are deciding about the test. Got it?
Yeah.
Okay. So here, resilience, pre-test and post-test, both are in interval or ratio level of measurement. There is no categorical here. There is nothing nominal or ordinal here. Okay, in the case of parametric tests. Okay, parametric testing of this particular. So when we are doing an intervention like this, it is definite we are playing with what? A pre-test and post-test with interval or ratio level of measurement. Definite. In that case, if both these are normally distributed, that means if pre-test and post-test are normally distributed, then we will call it, and then we will use paired sample t-test. If it is not normally distributed, then we will go for Wilcoxon sign rank test. Why it is sign rank test? I will explain to you. Just a minute. I will go to the Excel sheet once more. So here, these are the scores. Imagine these are the scores of resilience of a set of people. Okay. I will make this a little bigger so you can watch it. Yeah. And after the imagine this is the pre-test scores. Okay, there is a post-test set of post-test scores here. Okay, and imagine this is 12, this is 14, this became again 12, this stayed 12 even after the intervention. Imagine like that. This became 16, this became 17, this stood as 14 itself. This became 12, imagine, after the intervention. Intervention, it may happen like that also. Some of them may not get the effect of the intervention. Okay, all the medicines will not be appropriate for everybody, no? So this 15 became 18, this 15 became 13, imagine like that. This 15 became 19, and this 15 became 24. So for resilience pre-test, these are the scores, and resilience post-test, these are the scores, imagine like that. Now, I will rank this based on signs. Sign means SIGN, signs. SCIENCE, not that, SIGN, sign. Okay, what are the signs here? I will sign. 11 increase into 12, so I am putting that sign as plus. Oh, here there is a problem. In Excel, we cannot do that. Excel immediately consider it as what? A formula. So I will open a Word file. And here, and oh, that's our file itself. We studied about. So here there is a table. Okay. 11 increased to 12. So I'm putting plus here. Okay. 12 increased to 14. So I'm putting plus here. 12 increased to 12. I am writing a style. 13 increased to 16 plus. 14 to 17 plus. 14 to 14. So it did not change. So tile. 14 reduced to 12. So it became minus. Okay. 15 to 18 plus. 15 to 13, so it reduced, it became minus. Okay, 15 to 19 plus, and 15 to 24 plus. Now I will do the analysis based on these signs. Okay, that is why it is considered as Wilcoxon sign rank test. If you do it in SPSS, your result will come in the form of signs. Okay, so this is Wilcoxon sign rank test, which we may do in non-parametric to understand if there is an effect for a particular kind of intervention. Now, we said there is a pre-test and post-test. What happens if there is a pre-test and post-test and follow-up test? Then we cannot do these parametric and non-parametric tests. We cannot use this. Then we have to do some other thing, which we call as what? We'll call it as a repeated measures ANOVA or within group ANOVA. Okay, if there is only pre-test and post-test, we'll do what? Paired sample t-test or Wilcoxon sign rank test. If it is like pre-test, post-test, follow-up 1, follow-up 2, how many number of follow-up, no problem. We will go for what? We'll go for within group ANOVA or repeated measures ANOVA. If it has to be repeated measures ANOVA, there is only one condition. Each of these scores, the pre-test, post-test, follow-up test, etc., have to be normally distributed. If it is not normally distributed, then we will go for Friedman's ANOVA. And Friedman's ANOVA uses ranks. Okay, not signs, but real ranks, as we did in Mann-Whitney U and Kruskal-Wallis H. It will use the real ranks, and based on that ranks, they will assess the pre-test, post-test, and follow-up. Okay, this is what in Friedman's ANOVA, but it cannot completely depend on ranks because all the ranks will start with 1, 2, 3, and the second set of ranks also will move with 1, 2, 3. So it is not simply ranks. Along with ranks, there has to be signs also. Okay. So in Friedman's ANOVA, they will do like that. So if we are having a pre-test or post-test follow-up test, then the data is normally distributed. Then within group ANOVA, if it is not normally distributed, Friedman's ANOVA. All these are about what? Either an experimental design with what? With an intervention from outside, or the independent variable from outside and change in the dependent variable. The first one which we looked into was a quasi-experimental design. Specifically, we will call it as what? Ex post facto design with 2 group or 3 group on one side, and on the other side there is a continuous data. Okay. Now, what happens if there are no categories at all? Everything is continuous. Like resilience and self-esteem scores. Resilience score starts from imagine 80 to it starts from 80 and it will go up to 160 for the people. So 80, 81, 82, 83, likewise it goes. Self-esteem score starts from 40 and it goes till 100. So 40, 41, 42, 43. There are no categories for both these. Then we will not find out the difference or effect. Then we will look at what? We look at the relationship. Then we will look at the relationship. Okay, is it 7 o'clock? If it is 7 o'clock, I think I have to pick this.
So 5 minutes.
5 minutes.
But you can go ahead.
The person has cut that off. No problem. I will attend it after 5 minutes. So we will, if both the variables are continuous, if both the variables are in interval or ratio level of measurement. And if we want to find out if one is increasing when the other is increasing, then we will go for correlation analysis. And if the data is normally distributed, we will go for Pearson's product moment correlation. If the data is not normally distributed, we will go for Spearman row. We'll call it as what? Spearman row. And in Spearman row, as we said before, it will be completely ordered as per the rank. And then we will identify the correlation. In Pearson's R, we will give importance to what? Give importance to mean and standard deviation, and we will proceed. This is what we will do. And if we want to find out if the independent variable predicts the dependent variable, then we will go for regression. I think my time for discussion closes here. That means it is 7 o'clock. And I have arrange some other meetings also after the 7 o'clock after this class. So I cannot go too much after the 7. You can, to know more about regression, there are videos on regression in that particular channel. Okay, to know more about what the one-way ANOVA, t-test, and homogeneity of variance. There is something called homogeneity of variance. Please watch the videos on t-test, one-way ANOVA. Okay, you can find out, you can understand what is homogeneity of variance and how we will find out that homogeneity of variance. It's all, the videos are like this. The first step is about the theory of this. The second step is analysis using a software. Okay, there are two softwares which has been used. One is Demovi, it's an open source software. Second one is SPSS. So there are two different videos, but the explanations of the theory are same. Only the doing part is different. Okay, regression is also there. You can watch that also. I think many areas which you would like to study for this particular NET exam, it is there in the form of videos in this particular channel. You can open it and watch it and understand it. Try to learn better. Okay. If you have any more questions, just put it in the chat box. I will give a reply to that. If I stop sharing, I think I can see the chat box. If you need another session, just talk with consultancy wing and the team, and if they have the time to provide, I think if they request, I may come for a class. That's it. Okay, welcome for that. Welcome, and I'm happy that it helped you. Really, I'm worried with this small period of time. If you have told me in the previous class itself, these areas has been completely over and you need only take from here, I would have prepared. I'm already prepared, no problem to discuss. The time we may use the time from the beginning to the end without any issue, without losing anything, any part of the time. I'm really feeling a little bit of guilty regarding that. So sorry. But still, I think I have tried my level best to bring you the ideas on the analysis part.
No, sir, I don't think you need to feel guilty at all, because it was our mistake also for not telling you. And yeah, I'm just glad we told you that time itself so that we could continue to these things then. And we are really sorry, honestly.
Okay, same from here also. Okay, study well. Study well means we need not sit and cram so many knowledge inside. Understand things. Everything has what all the knowledge have some soft part in it. The only thing which we have to find out that is, where is that soft part? Identify that soft part, and we will go in with that. And love research a lot, then you will be able to understand it a lot. And reading or learning with anxiety or stress or fear will not help you. Just remember the theory of Barbara L. Fredrickson. If you are happy, you will understand more. There is a habit for at least some of the students, they will have a sweet before they go to the classroom. They think that the sweet will increase their capacity for the memory. Really, it increases happiness, positive affect, and positive affect increases the blood flow to the brain, and it increases your capacity to recall. So always be happy when you're going to the exam. While sitting there writing it, you will remember it well. If you are stressed, anxious, then you will spoil everything, definitely. So be happy always when you learn and when you write the examination. Okay. Okay, thank you. Thank you. Okay, then see you somewhere someday. Until then, enjoy learning research and statistics. Bye, everybody. If you have any feedback, you can say it. No problem. Otherwise, we will wind up.
Thank you, sir.
Yeah. Shall I wind up?
Yes, sir.
Thank you.